For almost as long as rockets have been around, people have dreamed of reusing them. But the concept always seemed a little bit too far ahead of its time. But then, in 2015, SpaceX proved that the first stage of a rocket could be fully and rapidly reused, dramatically lowering the cost. However, while the first stage of a rocket could be reused, the second stage was always thrown away. SpaceX tried reusing it, but it never panned out. Until one pioneering launch company decided to change everything. Since the first SpaceX rocket came down from the stars, countless companies tried to reuse their rockets and boosters, but most of them ended up being way too expensive or ended in tragedy. As of the making of this video, Blue Origin and SpaceX are the only companies which can reliably reuse a rocket, and only two companies plan on reusing a second stage, SpaceX and Stoke Space. For this video, we'll focus on the latter. Founded in 2019 by Andy Lapser, Stoke Space seems like it's developing an ordinary rocket, until you look up close. The first stage is like a traditional reusable booster, which comes back down using landing legs and an engine. But the second stage is absolutely groundbreaking, using 30 tiny rocket engines as one to harness the Aerospike effect. An Aerospike engine comes in two forms, toroidal and linear. A linear Aerospike is good for space planes, and it was actually proposed for a reusable space shuttle. And a toroidal Aerospike is better for cylindrical rockets like Stoke Space's. But what makes an Aerospike so advantageous? It all has to do with air pressure. This may be unexpected, but a rocket engine's exhaust plume is actually lower pressure than the air around it. You can see this at sea level, because a rocket engine's exhaust plume is squeezed tight by the air. And in vacuum-like conditions, the exhaust plume expands outwards because it's higher than the air pressure around it. This is important because of something called exhaust plume expansion. If a nozzle's exhaust plume diameter is equal to the diameter of the nozzle, it is optimally expanded. But if the plume diameter is wider than the nozzle diameter, this is called overexpansion, and it means you're wasting thrust by expanding it out sideways. And if a nozzle is underexpanded, it means that the plume is smaller than the nozzle diameter, and air will rush in, nudging the plume about. And if that's the case, don't expect very good things to happen. The Aerospike fixes this because at higher pressure, the exhaust plume is pushed in, as normal, and at lower pressure, it goes outwards without wasting energy. But if that's the case, why don't all rockets use them? The first issue is heat. This is a cutaway of a toroidal Aerospike. And the areas highlighted in orange show how much is exposed to the engine's several thousand-degree heat, which is a lot to cool. This is a problem that engineers would never solve. But Stoke Space does away with this by using the high surface area of an Aerospike to their advantage. By channeling supercooled liquid fuel into the Aerospike, they can use this as a heat shield for re-entry, and they would balance the inefficiencies of an Aerospike with the advantages of a heat shield to safely bring the rocket down to Earth. Which brings us to another problem. The vehicle must remain stable during re-entry, otherwise an unshielded part of the vehicle could be exposed to the superhot temperatures where it would melt away. So, the second stage is shaped like a cone, so the center of mass is nearer to the bottom where the heat shield engines and fuel tanks are, to point the rocket in the right direction. And to steer the rocket, the heat shield is at a slight angle to redirect airflow, therefore pushing the spacecraft in the right direction. To change direction, the rocket just needs to roll at a certain angle to redirect the airflow where it wants to. Combined with the ability to refuel in orbit, as Stoke Space claims, you'd be left with a vehicle that could go pretty much anywhere. And its Aerospike engine allows it to land on any planet, no matter how dense the atmosphere is. And I would absolutely love to see one land on the Moon or Mars someday. And who knows? Maybe in the future, we'll see lots of launch companies building rockets just like Stoke Space's for full rapid reuse. And maybe it would even become the industry standard. I hope you enjoyed this video. This has been Head for Science. Please remember to like and subscribe, and I'll see you in the next one.